All right. Per usual, we are recording this. Please don't say anything embarrassing. Um, we so we're going to continue the series on writing an RSS feed reader from scratch. Um, I don't generally have a specific. I usually don't figure out the specific thing that I want to work on until we get to the meeting proper. But I was working on this last night, and I thought, you know what, I need to test this stuff because I've written a bunch of database interface functions and I want to make sure that they work correctly. So now would be a good time to talk about how to write tests with PyTest. Let's see. So I've created this test.db.py, and we're just going to go ahead and throw this over here. And we're going to use this. We are going to use this to um, write our tests and make sure that all of these uh, all of these functions that I've written actually behave the way that they're supposed to. I mean, I am following the documentation in PonyORM, but I want to make sure that we're actually getting back what we're expecting. And if we're not getting back what we're expecting, either we need to just expect something different, or we need to make some adjustments to these functions in order for them to return the right thing. So the database interface is um, supposed to be a back-end agnostic interface for adding and removing items, RSS feed related items from our database. This is the interface is incomplete. I was just working on it last night. There's still a bunch of more functions that I need to write, but but if we can write our test framework and get that started, then that puts us in a good position to write the rest of the interface and immediately generate the tests and run them quickly. So the first um, the first thing we need to do is we need to initialize a database that is specifically for testing. So what we can do here is we can initialize um, our database using a SQLite in-memory database. And we can do that by providing a file name of :memory:, and that will create a database that only exists in memory. So we're not creating any files to go with it. Now, the one thing that we do need to look at is how are we going to reset the state of this database between tests. So that is not something that I had considered. I when I was thinking through this, but now that I look at it, one of the important things of testing is we need to test when things are in a known state, and if we don't reset the database to a default known state, and usually the easiest way to do that with an in-memory database is to just throw it out and reset it. But let's see. I'm not sure if uh, Pony provides a way to do that. So what I'm going to do, so the way this works is um, in our, uh, let's see, where is it? In DB model. So we have DB interface and oh yeah, that's right, it's over here, DB model. We create an ORM database object, and then we use that to define a bunch of entities, and then our interface basically makes modifications to these entities, and then the ORM is responsible for committing it to our database. But you'll notice in here that we don't establish what kind of database it is. We just have this DB object. Well, then what we need to do is we need to bind that DB to a provider, and in this case, the provider is SQLite, and then we give it whatever parameters are necessary to complete the binding. In this case, it needs a file name, and we tell it that it actually needs to create the database. Now, normally when we say file name, we're talking about a file name on disk. It'll automatically create that file on disk, and it will, and then it'll create it if necessary. It'll create the tables if necessary. It'll generate the mapping if necessary. All those things will happen automatically if we call initialize SQL. Well, so if we call it with memory, it's going to create it in memory, and it's going to call this bind on our DB object. But we kind of need to be able to unbind and rebind our, throw out our database and our binding between tests. So that is actually then becomes an open question as to how do we do that. So let's see, working with entity instances. So let's see. So we need to look up the database object, and we need to look at like how to unbind a database. Because when we set up our testing framework, we can set up fixtures, and those fixtures can have a setup and a teardown. And so the setup is pretty straightforward. We initialize the SQL part, but then we need to do some sort of teardown, which I had not considered. So let's see if we can even do it. Let's see. So we want to look at the ORM database object. So let's see the API reference. Let's see the database class. Okay, so there's our bind method, binds entities to a database. Yeah, you select the provider. So you can bind SQLite memory, SQLite file name, create database, true. The method can only be called once for a database object. All consequent calls for this method on the same database will result in a type error. Okay, so that makes sense. Commit, create tables, disconnect, close all data. Let's see, drop all tables, drop table on connect. Okay, drop all tables which are related to the current mapping. Ooh, we might need to, okay, so we might need to do something like this. Let's see, with all data, Pony drops tables only if none of them contain any data. Let's see, at least one of them is not empty. We'll get the table not empty exception. Or to drop tables with data, you should set with all data is true. Okay. Entity execute exists. Flush, generate mapping, get connection, insert. Is there any way that we can nuke our database? Okay. So we could do a drop all tables call. And then, let's see, we could call drop all tables. And then, let's see. Create tables checks the existing mapping and creates tables for entities if they don't exist. Also, Pony checks if foreign keys and indexes exist and creates them if they are missing. Okay. This method can be useful if you need to create tables after they were deleted using drop tables method. If you don't delete tables, you probably don't need this method because Pony checks and creates tables during the generate mapping call. Okay. Map declared entities to corresponding tables in the database, creates tables for key references, indexes if necessary. Okay, so it sounds like what we can do is call create tables at the start of our fixture and then drop all tables at the end. And that should reset our database to a known state. Okay, so the first thing we need to do is create a fixture, at least a fixture or a pair of fixtures that does this. So when I say a pair of fixtures, one of these fixtures is going to run per test, and the other one is going to run uh, only once per module, and or actually probably once ever. Um, so the main, yeah, it'll probably be once ever. So that'll be the initial setup of the database, and then the fixture that you use per test will create the tables and then drop them at the end of the test. So let's write those fixtures. Okay, so we need to go to the fixture section of the documentation, and we need to create a fixture. Now, fixtures are a very powerful function in PyTest. It allows us to set up um, um, our test. It allows us to basically manage the state of our test and do things that require like setup and teardown. So the first thing we're going to do is we're going to see. So we need to import PyTest, and we're going to the one thing that I'm not exactly sure how to do. Let's see. So I might need to turn source into a module here. I think. I'm not sure. So I'm not sure if we're going to be able to call our test code or call our code from our tests without turning this into a module. So I might have to think about that for a second. But we can still create our fixtures. So we're going to do import PyTest, and then we're going to do at, let's see, PyTest fixture, and we'll just create a basic fixture now. So we're going to do def, and we'll just call this database. Let's see. Yeah, we'll just call it database. That works. We're not going to pass it any arguments. It's a standalone fixture. And then we are going to, well, so the other thing we need to do is, I think we need to do from, so let's go ahead and add a new Python file, and let's go ahead and make this a submodule. Okay. So now we should be able to do from, let's see, source, rc dot, all right, and then we'll do db interface. And actually, let's do this from source import db interface as db, and then let's shorten it to dbi for our sanity. So we are going to call initialize SQLite. So we're going to do dbi dot, and then initialize, let's see, initialize SQL with our file name of memory colon. There we go. And that will set up our database. Now we want this fixture to only run once per we only want this to execute once per run of our tests. The other thing we need to do is we need to return our DB object. So let's see. So we're going to go from source. Let's see, from source dot, let's see, DB model. import DB. So that's our actual DB object. And then we'll just return that. So what this does is this makes sure when this fixture gets executed, it makes sure that our interface is initialized. So the other thing we need to do with this fixture is we need to determine when it's going to get run. And I gotta look because okay, dynamics. Let's see, scope. Determine scope, fixture scope. Okay, here we go. So we want to call fixture scope equals, and then we give it a scope. And what that scope says is how often do we need to execute this? Do we need to execute this just once for a module? Do we need to re-execute it every test? What do we need to do? So what we do is we take we specify session, and that means we only ever do it once for the entire session. So only once per time that we run our tests. Okay. So and then the higher level scopes are initiated first. So if this fixture gets used by any of the when we run a particular test, even if we cherry pick one test to run, it'll work its way backwards through the fixtures that are required to run that test, and it will eventually find this one, and it will run it, and it will remember what it returns. And so when a test requires this fixture, it'll use the same DB object across all of our tests. So now we're going to do another fixture that's going to do the setup and teardown of our database. And this is what we're actually going to use in all of our tests so that we know that our database is starting in a known state. Even though we don't necessarily aren't necessarily going to be doing anything with the fixture, the fixture's presence ensures that things get set up and tore down for each test properly. So we're going to go def, and we're going to call it session, and session relies on database. And then session is going to take our DB object. So if we come back to our API reference for our ORM, we are going to call, at the beginning of our test, we're going to call create tables. And we are going to call that on DB dot create tables. Let's see, yep, create tables. Then we are going to yield. And we don't actually need to yield anything because we're not actually going to be calling any of the methods on the DB there's like no object that we actually have to call things on. And actually we can do, since we're returning the DB here, we can do database create tables. That actually makes a little bit more sense. And then database, and then we're going to call drop all tables. And so what this will do is before the test runs that requires this fixture, it calls create tables. And then after the test is done, it calls drop all tables. And so now for all of our tests, we can just do def, and then let's see, test add, test add group. Let's do something simple. Group, and then let's see, test add group, and then we just use the session fixture, and this will ensure that our database is in a known state at the start of each test. Okay, so one thing is I have add group. I need to create a remove group Well, actually, no. We'll just let's see. We have get feeds. We don't have a get groups. Get groups. The way this interface works is actually not necessary. But well, let's just create it anyway. Oh, the other thing is our fixture is going to, we're going to need to start a session with this. So let's see. So with, let's see. And this is a Pony thing, so we need to import the Pony ORM stuff. And we need to go. So in order to create tables and delete tables on our database, we have to do it as, I believe we have to do it as part of a session. So we'll do with ORM dot DB session. And that will ensure that a session is created and destroyed in this context. I think we can, yeah, and so that's the other thing is now we don't have to worry about opening and closing, or opening, creating and destroying a session in our individual tests. So now we can just start calling stuff in our interface. So let's see. So we have add group. Let's make a function called get group. So add group returns a creates a group, which this act right here, this call right here, will actually create it and add it to the database. Now it's not actually committed until our session closes, but since we're going to drop all tables, it's just going to go away anyway, which is fine. Let's see. So we're going to call get group, and so we need to create a we need to let's see. So we can either have it return a list of groups or just a particular group object. So let's do the plural, and let's just have it get all of them. And we're going to do, let's see, we'll call select. And then we'll go ahead and sort it by name. Sort by group.name. Group.name. And then we will, I don't actually want to return Pony ORM objects from this interface. So we need to turn this, so this is going to be a query. And let's see. So did I change that? Yeah, I changed that to Q. So what we want to do is, let's see. We want to return a list, but we're going to do a list comprehension, and we're going to say G for, let's see, G to dict for G in Q. So that will iterate over the results of our query. And let's see, we're going to sort it by name. Okay, so this selects all of our groups, sorts the groups by name, and then returns the query object. We're going to iterate over that query object, and we're going to call toDict. Now, this is what allows the toDict call is what allows us to not actually have to deal with Pony ORM objects. It just turns it into a Python dictionary. So now we're all set up to actually write a test. So we're going to call, let's see, dbi dot add group, and we're going to give this group a name. Let's see, and we'll call it foo. Now, one of the things it does do is it does return the dictionary object, G. If we do, we should be able to do assert. Let's see, G and then name equals foo. All right. And then we can then do G, let's see, G list equals, let's see, DBI, get groups. So that should return us a list of these. And then we're going to assert length of G list is 1. And then we're going to assert that G list 0 name, typing is hard, name equals foo, like that. Okay. Now we're going to come over here. We're going to, we can actually execute these tests through PyCharm, but I'm going to do it just in the environment. So let's see. So I should just be able to run PyTest, and it should find and run the test. Okay, no module name source. Let's see, from source import DB interface as DBI. Okay, this is kind of what I was afraid of. So it did find our test, and it did try to import source, but it was unable to find it. Okay. So let's see. I think, let's see, how do we do this? Does anybody know how to deal with this off the top of their head? I'm trying to remember what the best way is. Because we got, so PyCharm doesn't have a problem with it because it's probably, let's see, where's my run my tests? Oh, I got to create a new test target. Okay. So PyCharm is fine with it because it has this holistic view of what my tests or what my package looks like, but PyTest doesn't see this. So let's see. Let's come back here, and if I run Python, let's see, tests testdb.py. Yeah, okay, no module named source. All right. So one of the things that PyTest apparently does is it removes the current working directory. It does not include the current working directory in the test. So now we need to set up a test configuration file, which I should have known that. So let's see, conf test, I believe is what it's called. Let's see. Conf test.py. Okay. Standalone test modules, conf test files. Okay. PyTest will find and realize it is not a part of package given there is no init file in the same folder. It will then add root, test to system pass in order to import test foo. Okay. Running PyTest with Python instead of PyTest yields nearly equivalent behavior, except the former call will add the current directory to the syspath. See also call. Ah, that's interesting. Let's do that. Let's do Python -m PyTest. Haha, okay. Now it broke for a completely different reason. But I would like to Okay, so I'll fix that problem later with add modifying conf test so it can actually import stuff. And let's actually look at why it failed. Database create tables. So transaction error. Function with DDL option cannot be called inside of another DB session. Okay. I do not know what that means. So, okay, so what that means is that we cannot do this inside of a session. Okay. That's fine. We will just go ahead and move it outside of our session that we've created, which should be just fine. Let's try it again. All right, now we have an error. Let's see. Object of function, object of type function. Oh, ha. Okay. So that's actually a problem on my part. I need to actually call that. See, we're learning here. And then if we run it again, okay, one passed, one warning, one error. Table's not, okay. Cannot drop table group because it is not, oh, right. So the other thing is I need to add in my drop tables call. Let's see, API reference. Here we are. Create tables, drop tables with all data equals true. Let's see, with all tables equals true. There we go. Now we should be able to run this. And it passes. And what's my warning here? The imp module is depreciated in favor of import lib, whose Python third-party Pony. Okay. All right. So Pony looks like one of its helper modules is using something that is deprecated. That's fine. Okay, but we've established that we can write our tests, and if the tests are correct, that they will work. Yes, parameter session is not used. Okay, so now we know that we can add a group, and that we can return it, or that we can add a group, and then we can get it later, and we can and that works correctly. So this is good because this verifies our most rudimentary code here of add group and get group. This is the simplest thing that we do. Okay. So now we can look at adding and removing feeds. So one of the things that you'll notice here is that we have we delete feeds using the feed ID, and that is because that's the one way that we can reference objects without in the ORM or in our database in general without using the ORM objects. So when I say delete feed, we can either delete it by name or we can delete it by ID. We're going to go ahead and use ID because the front end is going to be aware of the IDs of these objects. So just for fun, let's go ahead and print our G list here and rerun the test. Let's see. Session starts and collected. Okay, so I need to do, is it minus S? Yeah, there it is. Okay. So that causes it to dump standard out from our tests. So if you put print statements in your tests just to see what things look like, it will actually print it. It will actually print it to the console. If you don't include the -s, you will not get the standard out. So, and you'll see these a lot, like those of you who have done work with Voltron, you'll know that we run dash S because we do have lots of print statements in the tests, just so you can eyeball things quickly. Um, PyCharm does actually allow us to run these tests directly. But this gives you an idea of what that function get groups is returning. So um, yeah, so one of those things, one of those parts is the ID. And so this is actually the ID of the object in the database. And if we want to uh, delete a group or a feed, we should be able to do it uh, by name or by ID. Well, we'll probably want to do it by ID because as we return these objects to our front end, it's going to be aware of it's going to have available to it the ID. So it'll display the name, but it'll use the ID because the ID is always going to be unambiguous. Whereas you could potentially have duplicate names, but they'll have different database entries. You'll notice up here in my, let's see, over here in my feed, uh, we index based on our name, but we don't require that our names be unique. We only require that our group names be unique. Um, so if we decided to delete all of the feeds if we went into our UI and said, well, delete the feed with this name, or we said delete this feed, and we were doing the deletion by name, if we had multiple feeds with that name for some reason, which totally could happen, it'll blow all of them away. If we accidentally add the same feed twice and we want to just delete one of them, we don't want our delete interface to go through and nuke all of our instances of that feed. We only want it to delete the one that we've selected because that's the expected behavior. Okay. So let's go ahead and get rid of that. All right. So now, let's see. We want to be able to add a feed. So we have here group get group equals name. So I need to remember how the get call works. So if we're going to add a feed, one of the things that we can optionally provide is a group name. So we need to make sure that this code right here is working the way that we expect. So what happens if we call group.get and we specify a name that does not exist? So let's look at our API reference under the entity class. And I think if we just search this page for get open parentheses, yeah, there we go. Extracts one entity instance from the database, Python generator expression. Let's see, globals, locals, option returns an object if the object's specified parameters exist, none if there's no such object. There are more than one objects with the specified parameter. The function raises multiple found, use select to retrieve them, exception. Okay, we know that all of our groups are going to be unique because we have the unique specifier in our function. So this actually um, kind of begs the question is like, how do we want to handle the creation of new groups? So we could do it automatically on add feed. If we specify a group name that doesn't exist yet, we could just create it and stick it in the database. And we wouldn't want to call add group because that's not actually going to return a group object. I mean, we could use it, but then it gets a little tricky because we're calling toDict to kind of peel it out of its OR its Pony ORM object. But we really need it in its Pony ORM object because we want to specify group equals the Pony ORM object, not the dictionary that happens to represent a group. So what we will want to do is, let's see, I could call add, well, I mean, literally I could just do this. It's one line, so it's not worth putting in its own function. So if group is none, so if we don't find a group with that name, we'll go ahead and create it. Create group if it does not exist. Okay. All right. So, yeah. So if we specify no group, we, let's see. Yeah, if we specify no group, the group gets assigned to none, which is expected. If we specify a group name that does not exist, it creates it. If it does exist, we use it. Okay. Let's see. So let's add another test, def test add feed session. Okay. So we're going to go f equals dbi, and then let's see, add feed, and we're going to give it a name. We need to give it a URL. Let's see URL, and we're going to give it a home page. Why do I have a home page and a URL? So the feed items need URLs and URIs. Hold on. So let's see, feed, name URL homepage. Okay. The URL of the actual feed itself. Okay. And then the homepage, or the homepage for what the feed is actually representing. That's right. Those are two different animals. Homepage, and let's see, and then we'll leave the group name and everything else blank. Why is it complaining? Oh, 2 lines expected. Okay. And so then we should be able to assert rt, let's see, f, and then let's see, f name equals foo, and that's my phone. Go ahead and ignore it. And let's see, home underscore page. All right. And let's see, what else do we need? So the update rate is going to be a time delta 1 hours, and our group is going to be none. So let's see. So this is going to be group. So it's going to be either one or two things. Either group is going to not exist, or it's going to be none. So we'll find out. And then update rate is going to be a time delta. So let's see. From date time import time delta. I'm sure I'm going to need date time at some point. So we'll do time delta, and then we'll do hours equals 1. Okay. So let's see. So that gives us our, so this creates it adds the feed, returns the dictionary representation of that feed. Let's see, is there anything else we need to check? Feed. Okay, so last update rate. So these should be none. E tag should be none. Last modified should be none. But let's test what we've got so far. Yep, okay, so those passed. So let's go ahead and do the remainder of our tests. Let's see, let's grab you and copy you a bunch of times. All right, so let's see. Last update. Oh, these actually should be, let's do this. So last update, that should be none. E tag should be none. Let's see. Last modified, that should be none. And group is none. And items, I don't think exists. It's either none or it's empty. Or it doesn't exist. I don't think it exists, but we're going to stick it in here anyway and see what happens. In fact, I'm pretty sure. Yeah, in fact, I know it doesn't exist because when we printed out the group, the feeds that belong to that group do not exist. So, all right. Let's see. Okay. But let's just check. Let's just check it to make sure that our test failed here. Yeah. One failed, one test. Assert E tag is, oh, E tag is empty. That's interesting. Let's see. Last update is none. Assert blank is none. Okay. Let's look at E tag. Optional string. Okay. So last. Okay. Apparently, if we do an optional string, it comes back with an empty string instead of none. Good to know. Let's see, last modified. That one should be a string as well. Like that. And then now we expect it to fail on items. Yep, key error items. Okay, that's fine. So when you call toDict, you have the option of drilling down and including child objects or the relational objects. If you don't do that in your toDict call, you don't get the children, and we don't want the children, so that's fine. All right. So now we've got this add feed. So we know that add feed at least returns a proper dictionary of an object. So now we want to call get feeds to get our feedback. Now there's when designing the interface, I figured you're only going to call get feeds once at program startup or after you add a feed, in which case you're going to want to refresh everything anyway in your display. So you're going to want to just query the whole thing from scratch. So we're going to call our DBI. So what I did is I just created a single get feeds call that returns a list of dictionary object, or it doesn't return a list, it returns a dictionary of the feeds, and it maps from the group name to the feeds. Because in the interface, you're going to have everything organized by groups anyway. So you'll just get back the group name. And I notice now that we're out of time. So I'm going to go ahead and write this real quick, and then we'll call it a meeting. So let's see. And if it does not, and then there will also be a none group, which is for feeds that don't actually belong to a group. So we're going to say feed equals actually this should be fdict. Let's see, equals fdict none. And then the first item in the list. And then we should be able to run all of these asserts again. And it should just work. Did I remove items? I removed items. Okay. One failed. Attribute var none type has no attribute name. Okay, so then this was actually something I was wondering. Let's see. Okay, yeah, I'm doing this part wrong here. I'm forgetting to check and see if group is none. So let's see. So that's easy to fix. So let's see. F group name if f dot group is not none, else none. There we go. That'll do what I want. Yep, there we go. Okay, so we've established our basic testing framework here. We've written a couple of tests. We've already found a bug and fixed it in the get feeds method. So yeah, we're making progress. Yeah, so are there any questions? Okay, if not, we'll call it a meeting. Thanks for showing up. Yep, thanks. Thanks, David. All right, I will talk to you all later.